Okay. Good morning, dear students. Welcome to the lesson. It's me again. And I want to remind some things for you. We have to continue like this until some problems are sort of solved. So that's why I'm so sorry. Okay, let's start our lesson with worked examples. Okay, so in the last lesson, we have learned uh, multiples and factors. So what does it mean multiples? For example, what are the first three multiples of 12? 12 is even number. It doesn't matter. Just we need some multiples of 12. First three multiples of 12. It means like this, for example, as you see, 12 times 1, 12 times 2, 12 times 3. The answer is these three answers, 12, 24, and 36. Okay? To find these, multiply 12 by 1, 2, and then 3. If there is written not 3, first 5 multiples of 12, it was until to 60, okay? So, for example, we have 12, first 3 multiples of 12, and the first 4 multiples of 12 is 12 times 4 is equal to 48. And the second question is 300 a multiple of 12? It's a question of our question for us question. Is 300 a multiple of 12? How can you find the answer of this question? So, yes, 300 is a multiple of 12. To find out, divided 300 by 12. If it goes exactly, then 300 is a multiple of 12. So answer is exactly the new 5 integer plus positive integer. That's why the answer is yes. 300 is a multiple of 12. And there's some exercise 1.3. First one, list the first 5 multiples of these numbers. For example, I want to solve option D. Okay, so in others you can check yourself. Please stop the video and check yourself. So first 5 multiples of 8. 8 times first number is 1 is equal to 8. 8 times the second number is 2 is 16. And the third one is 3. 8 times 4 and 8 times 5. The last one is 40. Okay. And the second one, use the calculator to find and list the first 10 multiples of the big numbers. For example, H. Option H. 9,123. We need first 10 multiples of this number. How can you solve? You can use the calculator. Okay. You can use the calculator. For example, I want to solve the first option C. It's smaller than H. 75 times 1 and 75 times 2, blah, blah, blah. 75 times, and the last one is 10. 10 is equal to 720. Okay, so, and third one, list option A, the multiples of 4 between 29 and 53. Multiples of 4 between 29 and 23. After 29 is 30. 30 is multiple of 4. No, because the answer is not integer. When you divide by 30 divided by 4, the answer is 7.5. It's decimal number. That's why the answer is not 30. And the second one, 31 exactly is an odd number. That's why it's not, you cannot divide by 4. And the third one is 32. Yes, you can exactly divide by 4. His answer is 8 and blah 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 till 53. We need the answer. Okay, it's first one, and the second one is 36. 36 is divided by 4. The answer is 9, and 40. Third one is 40, and sorry, third one is 40, and the fourth one is 44. Answer is 11. Before that, there is 10. Okay, the lowest common multiple. If you remember, we had learned it already in 7th grade and 8th grade. Just we need now review it. Okay, so what does mean lowest common multiple or shortest LCM? The lowest common multiple of two or more number is the smallest number that is a multiple of all the given numbers. For example, find the lowest common multiple of 4 and 7. First of all, we need finding the sum multiples of 4. Let's write here. 4 times 1 is 4. And the second multiple of 4 is 8. The third one is 12. Fourth one is 16. Fifth one is 20, blah, blah, blah. Okay? And maybe let's write some 24 and 28 and 30, sorry, 32. Okay? Just it's enough. And the multiples of 7. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. And blah, blah, blah. So what was the question? Find the lowest common multiple of 4 and 7. Lowest common multiple. Lowest is not ascending, okay? And highest is ascending. So lowest common multiple of 4 and 7 is 28 and 28. Before that, 21 is not common with 4. And also 14 is not common with 4. And 7 already not same with any numbers before 28. That's why the answer is 28. As you see here also, 28, 28. Let's read the explanation. List several multiples of 4. For example, M4 does mean multiples of 4. First of all, several times we need to find the multiples of 4, maybe 10 times or 7 times it. For example, in 7, there is 1, 2, 3, 4 times. When you multiply with 4 first 4 number, it was enough. But some numbers, it doesn't enough, maybe. So exercise 1.4, find the LCM of 2 and 5. What is the LCM of 2 and 5? First of all, we need to write, like example, M2 and M5. So what is the 2 times 1? 2. What is the 2 times 2? 4, 6, 8, and 10. What is the 5 times 1? Is 5. 5 times 2 is 10. As you see, also the same numbers. The first, second number is 10. In M2, fifth number is 10. That's why they're same, and that's common. Multiple of 2 and 5 is LCM of 2 and 5 is 10. Okay, and others, please check yourself. You can solve yourself. Please stop the video and you can leave your also answers to common part of our YouTube video lessons. And factors. What does it mean, factors? A factor is a number that divides exactly into another number with no remainder, without remainder. So for example, 2 is a factor of 16. If you look carefully, 2 also and 16, both of them is even number, positive even number. That's why there's no, when you divide 16 to 2, we cannot find the remainder. Goes to into 60 exactly 8 times. So 1 is a factor of every number. The largest factor of any number is this number itself. For example, what is the largest factor of 16? Is 16, okay? Because you can divide by itself, and the answer is 1. And there is, we have some questions, and let's read these yellow part. F12 means the factor of 12. Okay, so factor of 12 is 1, 2, 3, 4, 6, and itself. It means in normal language, okay, so 12 we can divide with these 6 numbers without the remainder, okay? So find pairs of numbers that multiply to give 12, 1 times 12, 2 times 6, and 3 times 4, what the factors in numerical order. So the F12 or the factors of 12 are 1, 2, 3, 4, 5, 6. How many times? How many? There is a number. We have 6 number. Okay. So they are 1, 2, 3, 4, 6, and the largest factor of 12 is itself means 12. And F25. What is the factor of 25? Of 25 we can divide without each numbers. 1 exactly. 2 no, because 25 is odd number. 2 is even number. We cannot divide by each other. So 3 is exactly not. We cannot divide by 25. And 5 is, yes, 5 times 5 is 25. And the second number is 25. And the last one is, and the largest factor of 25 is itself means 25. So the factors of 25 are 1, 5, and 25. And others, option C, you can look. We haven't any more time. Okay, that's why. Let's open the next page. So exercise 1.5, list all the factors of 4. 4 is, first factor of 4 is 1 and 2, and last one is itself. Okay, and for example, 57. 57 is 1. Okay, 2, no. 3, yes. The 57 divided by 3 is, and there's 1 times and 19. Okay, and the last one is 3. Okay, it's enough. I mean, the last one is itself. So largest common factor of 57 is 57. And okay, for example, 100 is not difficult. You can check yourself also. Factors of 100 is 1, 2, 4, 5, and 10, blah, 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 blah. There is many times. And which number is each the set factor of the given number? Okay, let's check it. 14. The factors of 14 is 1. Okay. 2 is okay. 4, not okay. Because when you divide 14 by 4, the answer is not even or not integer. I'm so sorry. Okay. So we need integers without remainders. So the option is not factor of the given number. Okay. And let's check the other options. The factors of 15 are 1, 3, 5, 15, and 45. Not also, because what was the rule? Let's check it. Rule was, for example, okay, is a factor of number. The largest factor of any number is the number itself. And here, largest common factor is 15. That's why 45 is not a factor of 15. Okay, and also x and c 1, 3, 7, 14 also not. It's x also, and 33, 1, 3, 11, 22 is not also x, and 42. Where is 1 and where is 2? Okay, that's also it's not correct. So the first one or second one, yes, no. There's not any options is not correct because 42, there's not written first factor of 42 is 1 and the second factor of 42 is 2, and that's why it's not enough. We cannot say this correct. Okay, so the highest common factor, HCF, the opposite of LCM or inverse of LCM. The highest common factor of two or more numbers is the highest number that is a factor of all the given numbers. So for example, HCF of 8 and 24. 1, 2, 4, and 8 is the factors of 8. There's written factors of 8. There's 4 numbers. The first one is 1, and the last one is itself. And okay, what about 24? 1, 2, 3, 4, 6, 8, and 12, and 24. Okay, and there's we need common factor, highest common factor is ascending. Okay, increasing. Or which number in the same time the both have the highest common factor, exactly 8, because after 8 there is no any number, but before 8 is 4, it has got also 4, and it has got also 4, but 4 is less than 8. That's why it's not HCF of how can I say 8. Okay, so what was the explanation? Underlying factors that appear in the both sets, pick out the highest underlying factor, HCF. So answer is 8. Okay, there's we have some examples. I hope it's understanding for you. Find the HCF of each pair of numbers. For example, 3 and 6. What's the factors of 3 is 1 and 3. And what is the factors of 6? It's 3 and 6. 1, 2, 3, and itself 6. So common factor is 3, 3. The answer is 3. Okay. And I want to solve C. And what is the factors of 15? 1, 3, 5, and itself. And what is the 40? 1, 2, 4, and 20. Sorry, 10, 10, and 20, and itself. So there's we have 15 there, but there's not 15, and here also not 15. That's why the how can I say? I'm so sorry. We forgotten here 5. 5 times 8 is 40. That's why there's we have also 5, and the answer is 5. The HCF of 15 and 40 is 5. Okay, so you can find out how can I say? There's we have 3 separate numbers. Also, we need the finding the answers and opening the next page. And prime numbers, what does mean prime numbers? Prime numbers have exactly 2 factors, 1 and the number itself. 1 and itself, for example, x. What is the prime number of x? For example, 7 is 1 and 7. We can divide by only 1 and itself. So it does mean in mathematics language, it's prime numbers, okay? So composite numbers have more than 2 factors. Karışık sayılar, for example. The number 1 has only 1 factor, so it's not prime and is not composite. So 1 has only 1 factor. 1 times 1 is 1. Several times you can find you can write it, but the answer is not changing, so constant. That's why the 1 has only 1 factor, so it's not prime and is not composite. And I want to remind you, and the smallest prime number is exactly not 2. Okay, after 2 is 3, and 5 and 7, not 9, 11, blah blah blah. Okay, so and prime factors. What is the prime factors? First of all, let's remind what was the factors. Factors of 10, for example. Which numbers divide by 10 without the remainder? 1, 2, 5, and itself. It's prime factors, okay? Sorry, factors. But in here, which numbers of 10 prime factors? Exactly 2 is prime number, first prime number, and 5 also divided by 1 and itself. That's why it's also prime number. So prime factors are of 10, 2, and 5. Let's read. Prime factors are factors of a number that are also prime numbers. Every composite whole number can be broken down and written as a product of its prime factors. So you can also you can do this using three diagrams or using division. Both methods are shown in worked example 5 and here. Okay, so remember the product is the answer to multiplication. So if you write a number as the product of its prime factors, you are writing it using multiplication signs like this. 12, for example. So the prime factors of 12 is 2 times 2 times 3 is 12. And let's check it here. We have with the solutions, some questions. Write the following numbers as the product of prime factors. 36, first of all, find the factors of 36, or how can I say, as we have only two. In first step, only two factors of 36, 3 and 12. 3 is prime, that's why we cannot touch it. And 12 is not prime number, that's why we should also divide by two pairs of 3 and 4. 3 is prime, 3 is prime, and 4 is not prime, it's even. And 4 divided by 2 and divided by 2. So 2 also prime numbers. And the answer is 2 times 2 times, I mean 3 is 2 times 3. The answer is 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. Okay, so 48. But maybe you can solve like this. For 48, the factors of 48 is maybe 6 and 8. It's not problem. Also, you can take the same answers. So factors of 6 is 2 and 3. Also, we have 1, but 1 is not effective. So, and is also prime. And what is the factors of 8 is 2 and 4. Is prime also. What is the prime? Sorry, factors of 4, 2 and 2. There are also prime factors. 2 times 2 is 4 times 8, and 8 times 2 is 16. 16 times 3 is 48. 4 is not prime factors, okay? And, okay, open the next page. There are some examples. Express the following numbers as the product of prime factors. Option A. Okay, 3 diagrams, don't forget. What is the factors of 30, 2 and 15? 2 is exactly prime factor. Okay, 15 is odd number, so that's why you can write this separately. 3 and 5. 3 and 5, both of them prime number. So 2 times 3, 2 times 3 times 5 is 30. As you see, the answer is same. And for example, which one is smaller than others? 24, okay? Because of we haven't any more time, that's why I want to solve smallest number. And 24 divided by 2 is 12, and 2 is already prime number. And what about 12? 12 is 2 times 6. 2 is already prime number. Okay, there's we have 2 just now. And 6 is 2 times 3. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. As you see, it's not difficult. Okay, using prime factors to find the HCF and LCM. When you are working with larger number, you can determine the HCF and LCM by expressing each number as a product of its prime factors. There's we have fast forward. Let's read it, okay? You can also use prime factors to find the x square and cube roots of numbers. If you don't have a calculator, we will deal with these in more detail on page 11. Okay, so find the HCF of 100 68 and 180. What about these two numbers of HCF? First of all, finding the how can I say product of prime numbers. Okay, we need a product of prime numbers, but the factors of 168 is not these numbers. Maybe the other numbers also the factor of 168, but especially these numbers means the product of prime numbers of 168. Okay, and also in here 180, the prime factors of 180 are 2, 2, 3, 3, and 5. Okay, so 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60, 60 times 3 is 180. Okay, so what was the question? HCF of 168 and 180. And as you see, if you look carefully, there's we have 3 times 2, and in 180 is 2 times 2. And in answer, we have taken the smallest part of 2. And here also we have 2 2's. And here also 2 times 3, but in the first number is only 1 time. That's why we need to take the common part of numbers smaller. Okay, so and let's read first of all the explanation of this question, this answer, solution. First, express each number as a product of prime factors. Okay, these all numbers are prime factors. 2 is prime number, and 3 is prime number, and 7 also prime number. And use 3 diagrams of division to do this. Okay, I want to remind you, this one is our 3 diagrams. Okay, and underline the factors common to both numbers. Multiply these out to find the HCF. And here also 2 times, and here 3 times 2. That's why we should take 2 times 2. And which one is smaller than other? 3 is 1 time only. So answer is HCF of is 168 and 180 is 12 just. And the inverse of HCF is LCM. If you look carefully, the prime factors of 72 are 2, 2, 2, 3 times 2, and 2 times 3. And here 100, the prime factors of 120 are 2 times 2 times 2. There's also 3 times 2. And here also only 1 time of 3 and times 5. Okay, so if you look there carefully, as we have 3 times 2 because of the, how can I say, more of them 2 is 3 times. If there's we have 2 times 2, we didn't take it. Okay, so we needed to take it. And here also we have 3 times 2, just writing here 3 times 2 times, so 3 is 2 times in here, but here is 1 time. That's why we should take 2 times, which one is more, okay, because it's LCM. And times 5, and here also 5. So first express each number as a product of prime factors. Use 3 diagrams of division to do this. Underline the largest set of the multiples of each factor, largest, and list these and multiply them out to find the LCM. So let's multiply. 2 times 2 is 4, 4 times 2 is 8, 8 times 5 is 40, 40 times 9 is 360. So answer is 360. Let's to this first one is 48 and 108. What was the question? Find the HCF of these numbers by means of prime factors. First of all, we need the prime factors of 48. Let's write it. 2 times 2 times 2 times 2, and 2 times 2 is 4, 4 times is 8, 16 times 3 is 48. Okay, and what about 100? 108, you can find the HCF of the prime factors of 108. First of all, 2, 42, 54, 2, 27, 3 times, 9 times, 3 times 3, 3 times 1. So as we have 1, 2 prime factors, 3, 3, 3. 3 times 3, 3 cubed times 2 times 2, 2 square. Okay, the answer is 108. Okay, so what was the question? HCF of these numbers. What was the HCF, for example, in the first question, 168 and 180? Exactly, we should take the smaller factors of both numbers. For example, 2 is, which one is smaller? 2 exactly. That's why we should take also from here to just 2 times 2, 2 times 2, okay? And which one is smaller than other? 3, as we have only 1 time, but here 3 times. So 2 times 2 times 3 is 12. And HCF of 48 and 108, the prime factors, is 12. Okay, let's check again. As we have how many times 2? 2 times 2 is 4. 4 times 3 is 12. I mean, it's okay. If we have some wrong, you can leave your comment. Okay. So for today, it's enough, guys. Thank you for your attention. See you in the next lessons. Goodbye.